Hello, everybody. It is Mr. Odom, and I'm going to go through section 9.2, surface area of pyramids. So, if you understood how to find the surface area of prisms, then this lesson will be pretty straightforward for you. So, we have a quote that we can reflect on. I know for sure that what we dwell on is what we become. So, I'm going to pause the video so that you can reflect, write some thoughts in your composition book or your journal. If you want to share your thoughts with me, you can. And just always remember, you don't have to. These are your thoughts. But I enjoy the few of you that do. That's awesome, but you don't have to. So I'm going to pause now for reflection. Okay, so we are back and let's get started with this lesson. So there's our tools, same tools as always. Now we need to be able to find the surface area of a pyramid. Okay. And we are going to focus on regular pyramids, and we'll talk about what a regular pyramid is soon. And you see the definitions there in bold. Those are words, phrases that you need to know the definitions of. So let's get started. So a regular pyramid is a pyramid whose base is a regular polygon. What does that mean? A regular polygon is a polygon where all the sides are congruent. So a square is a regular polygon. An equilateral, equiangular triangle is a regular polygon. Okay. Um, so in a regular pyramid, the lateral faces are triangles. And you can see here in the net, um, when this pyramid is opened up, you can see where the slant height is. The slant height is the height of one of the lateral faces. Okay, so to find the surface area, I need to find the area of the base. So let's see here. So we can have a formula. It's the area of the base. That looks very similar to area of the bases when we were talking about prisms. So AOB represents the area of the base plus the area of the lateral faces, which will always be triangles. And if I find the area of one triangle, I just have to multiply it by the number of triangles that I have for my lateral faces, and that will give me the lateral surface area. Okay, let's do an example. Let's find the surface area of this regular pyramid. Okay, so my base is a square. How do I know that? Because they only give me one dimension for the length of one of the sides of the base. So that means the base is a square. And the slant height is going to be this value. It's pointing at the height of one of the slanted triangles. All right, so you can draw a net if you want. If it's easy for you to find the surface area, I encourage you to draw a net and then label it, and it'll make it easier for you to find the area of the base, which is a square, and to find the area of one of those triangles, which is the base times height divided by 2, which is the formula for the area of a triangle. And then you just add all those things together. Okay, the area of my base is 25, and then I have 4 triangles, so 20 plus 20 plus 20 plus 20. Or another way you could do this, instead of doing that, is you could say surface area equals 25 plus 80, because you just multiply the area of one triangle times 4, and that gives me the area of all of the lateral faces. Okay. And I get 105, and remember it's 105 square inches, or I can write it this way, 105 inches squared. All right. So that's how you find the area, surface area of a pyramid. So here's one for you. What is the surface area of a square pyramid? So they tell you what the base is going to look like with a base side length of 9 centimeters and a slant height of 7 centimeters. So the video is going to pause so that you can work that problem out in your composition book. Okay, so we're back and let's see, what did I do? Well, first I thought it'd be kind of cool to draw a pyramid. So that way I can label it. So there's my base side length of 9 centimeters and my slant height of 7 centimeters. I wrote down my formula. Surface area equals the area of the base plus the area of the lateral faces. I go over here and I calculate that area of the base. And it's 81, so it's 81 centimeters squared. 81 centimeters squared. And then I go ahead and calculate the area of the lateral faces. I find the area of one of those triangles, and then I multiply it by 4, which is what I did here. So that gives me the area of the lateral faces. And then what do? I add those two measurements together and make sure that I include my units, centimeters squared. Okay, so that is how you find the surface area of a pyramid. Let's do this again, only this time, this is called a triangular pyramid. Why? Because the base is a triangle. And so let me highlight that for you so you can see, whoops, that where's my highlighter? Right there. So that base is a triangle. Okay, so there's my base. So the way that we solve this is exactly the same way. And if you want to draw a net, you can. And you can see that now I have my base as a triangle, so I have to find the area of the base using the formula for the area of a triangle. I find the area of one of the lateral faces, which in a triangular prism, there are 3 lateral faces. So I find the area of one of them, and then and um, the area is 70, and I could multiply that by 3 and have the area of the lateral faces as 210. So I could just add 43.5 to 210. It's another way to look at it. And then I do that, I get my area, my surface area, and remember it's 253 square meters, or 253.5 square meters. All right. So triangular pyramids, sometimes students get confused with these different heights. So maybe a net, if you don't see it over here, how these different heights are used, what they're pointing to, then draw a net and label it. So then I can see that 14 is my slant height, 14 meters, and I see that 8.7 meters is the height of my base, which just happens to be a triangle. All right, let's look at this problem. A roof is shaped like a square pyramid. That's helpful. One bundle of shingles covers 25 square feet. We want to know how many bundles should we buy? All right. So the base of the roof doesn't need shingles. So all we have to do is find the sum of the areas of the lateral faces of the pyramid, or the lateral surface area. Okay, so I find the area of one of those triangles, and it has a base is 18 feet and the height is 15 feet, and there are 4 of them. So I just add them together, or take 135 and multiply it by 4. So I know one bundle covers 25 square feet. So it will take, and what do? I take the 540, which is that lateral surface area, divided by 25, and I get 21.6. So can I buy 21.6 bundles? No, I can buy 22 bundles and just know that on that last bundle, I won't use all of it. All right, so buy 22 bundles of shingles. All right, so here's a problem for you. Okay, first, tell me what kind of pyramid is this? All right, if you said a triangular pyramid, you would be correct because the base is a triangle. So now I want you to find the surface area of this triangular pyramid. All right, so we're back. Let's see, what did you get for your answer? Here's my formula. Surface area equals area of the base plus area of the lateral faces. I find the area of the base first. I draw a triangle and I label it with the height, which is 5.2 feet. That's what this represents, the height of my base. And this is the length of the base of that triangle. So I can find the area of that. And what do I get? I get 15.6 feet. And then I have the area of my lateral faces, which is there are 3 lateral faces. I find the area of one of them and I multiply it by 3. So I get 90 square feet. So then I need to take my 90 and add it to my 15.6, and I get a surface area for this triangular pyramid of 105.6 square feet. So that's it. So I'm going to stop the video here so that you can ask me questions if you have them. All right, so I'm back, and as always, um, this is Mr. Odom, and you know you know that I'm out, right? You already know that. Have a good day, everybody.